Okay, example number 2. Okay, example number 2. They have now asked us to solve for a side of a triangle. Okay? So once again, the other ratio we know is tangent ratio. So let's set it up. Tangent theta is equal to opposite over adjacent. Okay? Now, let's quickly name our triangle, our opposite and our adjacent sides, so we know what to do. I've only been given one angle, 58, okay? And they want me to solve for side x, okay? Now, I'm going to need to have, side x is what in relation to angle 58? It's the opposite, okay? So x is our opposite side. So we're going to replace our opposite with the letter x, okay? Tangent. We replace the opposite with the letter x. Our adjacent side is which when we're referring to 58 degrees here? 4.2. So we replace A with 4.2. And finally, theta. Do we have a measurement for theta? Yeah, what is it? 58 degrees. So let's replace theta 58 degrees. Okay? So now I'm trying to solve for x. And we're going to do this one step at a time. First of all, I have tan 58. That means I can solve for it. I can solve for tan 58. I'm going to put that in my calculator. Tangent 58, 1.6. Let's leave it at that, okay? Let's set it right in the rest. So we have 1.6. So I now know 1.6 is equal to x divided by 4.2. Well, I need to isolate x, so how do I move 4.2 to the other side? Multiply. So this becomes 4.2 multiplied by 1.6 is equal to x. So we have our 1.6. I'm just going to times the answer. You can do that on all your calculators. It'll give you a more accurate reading. Equals 6.72, we'll call it. So x is equal to 6.72. Now if we quickly take a look at that, that means that that side of the triangle is 6.72. I've now solved for it. Okay? I've solved for that side of the triangle. Do you guys have any questions about that? Example number 3. They want us to solve for the missing side, which is our k. Okay? So I'm just going to make a little room here. Our ratio, again, is tangent theta is equal to opposite over adjacent. So first off, I'm going to have to name my triangle. I have the measurement of a side right here. What is opposite of that side? AC would be the opposite side. So I'm going to replace our O in the equation with 8.7. Tangent equals, here we go, we have our 8.7. Our adjacent side refers to what? K. We don't have a measurement. They're calling it K. So that's going to be our variable. We're replacing A with K. We're trying to solve for K. And finally, what angle are my opposite and my adjacent referring to? Are 41. We're referring to angle B. So I'm going to replace my theta with 41. As notice, theta is now 41. Okay? So there are always 3 variables in these ratios. What the angle is, what the measurement of the opposite side is, and the length of the adjacent side. Always 3 variables. You're going to need 2 of them to be able to solve for the other. So finally, we're going to try to solve for our k. Now, same idea as before. Tangent 41. I hit tan 41. It's simple as that. It's not the other one when we're solving for an angle, we always use the inverse. When we're solving for sides, we don't have to use the inverse. They've already given us an angle. Tan 41 is 8.69, we'll call it. So 0.69. 0.8, what did I say? 8.6, no, 0.869 is equal to 8.7 divided by k. Now, this one's a little trickier. Think of these as all as individual numbers. I got to isolate k, and k's on the bottom. So technically, I got to bring k to the other side first. So it's no longer on the bottom of the fraction. So what's that going to leave me with? When I move k, I have to use what operation? Multiplication. So when I bring k to the other side, it'll say k times 0.869 is equal to 8.7. Okay? Think of them as all in brackets. And remember, I'm trying to isolate for k. So now to isolate k, what do I need to do? I'm going to have to divide both sides. Oh, I forgot about that. By 0.869. Okay? 69. So the next line is going to read like this. K equals 8.7 divided by 0.869. So our K, I'm going to put it in here right now, 8.7 divided by 0.869, 10.01. So our K is equal to 10.01 millimeters. Okay? So I've solved for K. I now know the distance of that. Now, I'm just going to show you a few other things just because I want you to be able to connect this. Okay? So I'll do it for both of the triangles. First off, we'll start with example 3 and then we'll go backwards. I can find the other measurement of the angle in here very simply. All triangles, angles are going to add up to 180 degrees. So if I'm looking for this angle here, we'll call it theta. I know that theta is going to equal 180 subtracted by the other two angles, which are 90 and 41. Theta will equal 90 subtract 41, which equals 49 degrees. So the other angle is 49. I solved for that very easily. And finally, there's a theory that will help me find the hypotenuse of this quickly. The Pythagorean theorem. This is all a review of grade 9, okay? So I'll quickly do that. A squared plus b squared equals c squared. Now I know the a and b doesn't matter which I call them. We just know we're solving for c. So we'll call it a 8.7 squared plus 10.01 squared equals c squared. 10.01 squared equals 100.2, we'll leave it at, and 8.7 squared, 75.69, we'll put it at 0.69. C squared will equal that plus 100.2, gives me 175.89. And finally, C, I have to square root both sides. Remember, this is all a review of grade 9. I've got to find the square root of that, which is second function, 175.89. 13.23, okay? So I know that's a little extra work texting that part of this, but I wanted to review those grade 9 concepts. So that means the hypotenuse of this, ooh, I missed it, is 13.26 millimeters, which makes sense. Hypotenuse should be the longest side. We're focusing on tangent ratio, but just know that you can do those other things. If you get stuck at one point and need to find the other angle, you could quickly do that. And if you need to find the hypotenuse, you can put in Pythagorean's theorem. Okay. Okay. Your homework, it's in Blue Notebook, page 412. It tells you to do text page 362, numbers 1, 6, 9, 21, and 20.